Hi guys, welcome to another video, and today we're looking at work done. Now that word work done, it simply means that when we put force into an object to make it move, well, we've done some work. Now in physics, energy transferred is exactly the same thing as work done. So in physics, in the exam, you may see these two terms used interchangeably, but they both mean the exact same thing. For us to do work, energy has to be transferred. Now we can calculate how much work is done or how much energy is transferred by using a simple equation. And that is this equation here, where W stands for work done, and because work done and energy transferred are the same thing, we measure them in the unit joules. F stands for force, because remember, we have to apply a force to make an object move, and that force is measured in newtons. And D is the distance, and that's measured in meters. How far did that object move? Well, let me give you guys a practical example. Let's say this is me, and I'm going to push this table 2 meters along the ground. I have to push that table with a force of 30 newtons to make it move. What would be the energy transferred? Well, I would use my equation, and I can start to plug in the numbers. The force is 30 newtons. That's the force I've had to apply. And the distance that that table is going to move is 2 meters. That means for this activity, or for this work that I'm doing, I've transferred 60 joules of energy. In your exam, you may not have to use the equation straightforward. And we've done this in quite a few videos where you will have to rearrange this equation. So to rearrange it, work done or energy transferred would go at the top, and force and distance would go in the bottom two. When work is done to overcome or to make an object move, usually we have to overcome friction. There would have been friction between this table and the ground. So when I put the work in, I had to overcome that friction, which means that some of that energy is transferred as heat. As those two surfaces rub together, that heat would end up in the surroundings. Okay guys, thanks for tuning in. Stay in touch for another video.